In this video, we're going to look at the effect of temperature on the spontaneity of a reaction. So what determines if a process, meaning a chemical reaction or a physical process, is spontaneous? Generally, it depends on the enthalpy change for the reaction, the entropy change for the reaction, and the temperature of that reaction. And of course, we can put all of these three things together, enthalpy, entropy, and temperature, to give us the Gibbs free energy change for that reaction. And we know that if the Gibbs free energy, or delta G, for a reaction is negative, then that reaction is spontaneous under those conditions. If delta G is positive, that process is non-spontaneous under those conditions. And if delta G is equal to 0, then that process is at equilibrium. So let's look at each of these and see how they affect the sign of delta G and therefore the spontaneity of the reaction. Let's start by looking at the enthalpy change for the system. Reactions that tend to release heat, reactions that have a net release of heat, tend to be spontaneous. So exothermic reactions, a negative delta H, those reactions are more likely to be spontaneous because they're releasing heat, which is energy. And reactions that absorb heat tend to be non-spontaneous. So endothermic reactions, a positive delta H, those reactions tend to be non-spontaneous. And we can see this mathematically if we look again back at our delta G equation, our Gibbs free energy equation. If you had a reaction where delta H was negative, if this reaction was negative, or excuse me, if the value of this delta H is negative, then that tends to make delta G negative. So the more negative, the larger, more negative this value is, the more likely delta G is to be negative. The more likely the delta G is to be negative, the more likely the reaction is to be spontaneous. And of course, we could say the opposite. If delta H is positive, then delta G is more likely to be positive, and the reaction is more likely to be non-spontaneous. Let's take a look at the entropy change for the system. Reactions that tend to have a net increase in entropy tend to be spontaneous, and reactions that have a net decrease in entropy tend to be non-spontaneous. And we can see again this mathematically if we look at delta S for the system. When delta S is positive, since we have a negative sign here, when delta S is positive, delta G is more likely to be negative. So the larger the entropy change, the larger, the more positive the entropy changes, the more likely delta G is to be negative for that reaction. The more likely delta G is to be negative, the more likely the reaction is to be spontaneous. And of course, the opposite is true. When delta S is negative, delta G is more likely to be positive, and the reaction is more likely to be non-spontaneous. Now here, we're saying more likely because, again, it doesn't depend only on entropy. It depends on both entropy, enthalpy, and the temperature. But we can just make some general statements. That's all we're doing here. Well, we've looked at enthalpy and entropy. What effect does the temperature of the system have on the spontaneity of a chemical reaction or physical change? Well, increasing the temperature increases the entropy of the system. Higher temperatures, we have more molecular motion, more randomness, more disorder, so higher entropies. And decreasing the temperature tends to decrease the entropy of the system. Lower temperatures, there's less molecular motion, less randomness, less disorder. So how does that affect delta G? Well, let's look at it again mathematically. At higher temperatures, since we're multiplying the temperature times the entropy change, as this temperature gets bigger, this T delta S term becomes larger and larger relative to our delta H. So at higher temperatures, the entropy term tends to be larger, more likely to be larger than our enthalpy term. Thus, at higher temperatures, the entropy change is more likely to determine if the reaction is spontaneous or not. So if you have a positive delta S, the larger the temperature is, the more likely that is to be delta G is to be negative. If you have a negative delta S, At higher temperatures, it makes it even more likely that delta G will be positive. So take a few minutes and convince yourself of that relationship. Okay? And conversely, at lower temperatures, then this T delta S term will be smaller relative to our enthalpy change. So at lower temperatures, the enthalpy tends to determine whether the reaction is spontaneous or not. So at high temperatures, the entropy term tends to dominate and determine whether the reaction is spontaneous or non-spontaneous. At lower temperatures, it's our enthalpy change that tends to dominate and determine whether delta G is positive or negative. So let's illustrate this by filling in this chart. Okay? Let's say that we had a reaction, and that reaction had a positive delta H and a positive delta S. Is the reaction likely to be spontaneous or non-spontaneous at low temperatures? And is it likely to be spontaneous or non-spontaneous at high temperatures? Pause the video and see if you can fill in this table for each of these conditions: positive delta H, positive delta S, positive delta H, negative delta S. See what you think. And again, these are general statements. We can't say for certain, but fill in the table with what you think is the most likely outcome. Pause the video and give it a try. Okay, so if we have a positive delta H, a positive delta S. At low temperatures, remember low temperatures, we said that lowers this term over here, the entropy term, and it gives us the assumption, we can make the assumption that the delta H value will determine whether the reaction is spontaneous or non-spontaneous. So here we have a positive delta H, which tells us at low temperatures, the reaction is more likely to be non-spontaneous, positive delta G. At higher temps, well, then it's going to be this T delta S term is going to be the dominating factor. And delta S is positive. It means the reaction is more likely to be spontaneous, a negative delta G. Okay. What if we have a positive delta H, a negative delta S? Well, at low temperatures, the delta H term is going to be the dominant one. And here delta H is positive, so that means the reaction is more likely to be non-spontaneous at low temperatures. At high temperatures, the entropy term is the dominant one, and we have a negative delta S, so that means the reaction is more likely also to be non-spontaneous. So here, at high and low temperatures, our reaction will be non-spontaneous under these conditions. Okay. Here we have a negative delta H, a positive delta S. At low temperatures, delta H is going to be the dominant term. A negative delta H means the reaction is more likely to be spontaneous, negative delta G. And at a positive, at a high temperature, the positive delta S term will be the dominant one. So that tells us, again, the reaction is likely to be spontaneous, a negative delta G. So under these conditions, the reaction will be spontaneous at all temperatures. And finally, negative delta H, negative delta S. At low temperatures, what's the enthalpy term going to be? It's negative, so that means it's likely to be spontaneous. And at high temperatures, our entropy term is more likely to determine delta G. So at high temperatures, our delta S value is negative, so that tells us that the reaction is more likely to be non-spontaneous at high temperatures. So appreciate the relationship of delta H, delta S, and delta T, how all of these play together or interplay to determine whether a reaction is spontaneous or non-spontaneous. Be sure you review these and appreciate how they relate to each other.